All right, next in our unit, we're going to make sure that we remember how to graph linear equations. And we were going to start these notes in class yesterday, and then we were going to do more notes to make sure we understood them today. But since we didn't do that yesterday, that means we have two sets of notes we're looking at today. Depending on how long the video gets, I probably will not do all the examples. So we're starting off with these notes, and then we're going to go to these notes, just so you guys know what's coming. Okay, so graphing linear equations, the most common form that you guys are probably used to is slope-intercept form. That's y equals mx plus b. And so if you recall, the m is the slope, which we usually talk about as rise over run. So rise means how far up or down you go. So if the number itself, and the number that I'm talking about is the coefficient for x. So if the number itself is positive, you're going to go up. If the number itself is negative, you're going to go down. And then the denominator of the fraction tells you the run or how far you go to the right. And then the number on the end, the b value, is just the y-intercept. All right, so for the first example, we have y equals 1/2 x plus 7, so that means we have a y-intercept of 7. And then from there, we're going to rise 1 and run 2. And you'll notice that I said we're going up because the number itself is positive. So up 1 over 2, up 1 over 2, up 1 over 2. The only time I want to move to the left instead of to the right is if I've run out of space, and then I'm doing the opposite thing to go backwards. So down 1, left 2 would be the opposite. So down 1, left 2. All those points in there, and then I'm always going to make sure that when I graph the line, I have arrows on each end to show that when it gets past my grid, it continues on. All right, for the next problem, I can see that I have a y-intercept of 1. And then for the slope, I don't have something that's been expressed as a fraction. I just see a -2. So the first thing I'm going to do is rewrite this equation as a fraction. And anytime you have a whole number that you want to write as a fraction, you just need to put it over 1. And so that means that we're going to rise a -2. So we're going to go down 2 and then to the right 1. So down to right 1, down to right 1. And then to go the other direction, we're going to go up to left 1. And again, I'm making sure to put arrows on both ends of my line. All right, next we have vertical and horizontal lines. So when you see an equation that doesn't have a y in it, it just has x equals a number. What that literally means is that x always equals 3. So that's going to give you points like my graph should have the point 3, 0. It's going to have the point 3, 4. It's going to have the point 3, 9. It's going to have the point 3, -10. It's going to have the point 3, -3. And if you can see that when you graph those points that always have an x-coordinate of 3, that creates a vertical line. So that tells us that anytime we have an equation where x equals a number, that's always going to give us a vertical line. So x equals 3, x equals -2, x equals 0, x equals -100, all of those would be vertical lines. Next we have y equals -5, so that means y always equals -5. So we could have the point 0, -5. We could have the point 2, -5. We could have the point 7, -5. We could have the point -5, -5. And if you can see, if we were to connect these points, that would give us a horizontal line. So anytime you have an equation written as y equals a number, that's going to give you a horizontal line. All right, let's go ahead and flip the notes over. Another form of a linear equation is the standard form. So that's ax plus by equals c. And what this means is that the y is not by itself. The x and the y are typically on one side, and they often have coefficients, which means they have numbers in front of them. So there are two methods for dealing with problems that are written in standard form. One method is the cover-up method. And with the cover-up method, you look for the x-intercept and you look for the y-intercept. So if I look for the x-intercept, that means that I'm looking for the point that's on the x-axis. And you can see that on the x-axis, the y-coordinate for all of these is 0 because we haven't gone up or down at all. So that means that for the x-intercept, we're going to have a y-coordinate of 0. So if I think about plugging 0 in for y, 4 multiplied by 0 is 0, and that's just not going to be there. It's going to be nothing. So I'm going to end up with 3x equals 12. And so that's what they mean when they call it the cover-up method, is that I know that y is going to be 0, so I can cover it up. So 3x equals 12. I'm going to go ahead and divide by 3, divide by 3. 12 divided by 3 is 4. So the x-intercept is 4. Then for the y-intercept, I know that anywhere along the y-axis, the x value is 0 because it hasn't moved left or right at all. So the x value is going to be 0. And if I were to look at the equation and plug 0 in for x, I get 3 times 0 is 0. So it's like that's not even there. I'm going to cover it up. And I get 4y equals 12. And then I'll go ahead and divide by 4 on each side. And so that's 3. So the y-intercept is 3. Now, I only have 2 points, but I only really need 2 points, and I can actually graph that. So there's my line. That wasn't as straight as it could have been, but it was close. All right, so we've got the cover-up method, and then the other method is to solve for y. And when you solve for y, what you're doing is you're taking the equation and you're rewriting it in the slope-intercept form so that it looks like this. So it looks like one of these two. So when you solve for y, that's what you're doing. Okay, so I'm going to go ahead and write the equation down again. So first thing, to get the y alone, I'm going to take the 2x and I'm going to move it over to the other side. So that gives me negative 3y equals, and then since I know that I want it to look like the other sheet, or the other side of the sheet, that means that I want the x to come first and the number to come second. So I have a 2x and a 9. They cannot be combined. They're not like terms. The x needs to come first. The number needs to come second. I put plus 9 because the 9 itself is positive, and so it needs the plus in front of it. All right, at this point, we can divide by negative 3. And what I'm doing is I'm dividing each term by negative 3. All right, so I've got y equals 2x divided by negative 3. I'm going to say that that's an x, and then this is the fraction 2/3. And I'm just taking the negative and putting it to the front. So negative 2/3 x. 9 divided by negative 3 is negative 3. So that is the equation that we're graphing. Now it's slope-intercept. So now we're going to say the y-intercept is negative 3. And for the slope, we're going to do down 2 to the right 3. So down 2, right 3, down 2, right 3. And same thing in the opposite direction. And then we have our line. Okay, so let's go ahead and look at the other page of notes. On this page of notes, I just put some problems in there that would maybe mess with people a little bit. So for instance, with this problem, students look at this one and they say, oh, I really like the cover-up method, so let me go ahead and do that. And they'd be like, okay, the cover-up method tells me that the x-intercept is x equals 0. Okay, so my x-intercept is 0, 0. Okay, and then if I do the cover-up method, all right, my y-intercept is 0, and 0 divided by -1 is 0, and then they say, okay, I did the cover-up method and I got the point 0, 0, and 1 point is not enough to make a graph. So if you do a problem like this, the cover-up method is not a good option. Okay, so if you're doing a problem like this, that means we have to solve for y. Now, I could do the same process I did on the other notes. I could move the x to the other side and then get y alone. But it's actually a little bit easier with the way that it's written to just take the y and add it to the other side. So I'm going to go ahead and do that because that's going to make the y alone. It's just going to be written a little bit backwards. All right, so I get x equals y. I'm going to flip those around just so I feel a little bit more comfortable with them. Y equals x. And here some students wouldn't recognize that this is actually written in slope-intercept form. It's just that the number in front of x isn't written there, so that means it's a 1. If I want to write it as a fraction, I just need to put it over 1. There's no number on the end, which means that the number on the end must have been a 0, so plus 0. So that means we're going to go up 1, we're going to go to the right 1. So starting at 0, which I had, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. And so this is the equation that I'm graphing. All right. Let's go ahead and do the example problem that's right underneath that. If we look, if we could try to do the cover-up method on this one. If I wanted to find my y-intercept, negative y equals -4. Easy, okay, that means that positive y is positive 4, so we know what our y-intercept is. But if I look for the x-intercept, if I do the cover-up method there, then I have 5x equals -4. And if I divide the 5 over, then I get a fraction, and that's not as easy to work with. So I'm going to go ahead and solve for y on this problem. So 5x minus y equals -4. I'm going to go ahead and take my x and move it over to the other side. So that leaves me with -y equals, and then I remember that my goal is to make it look like this. So I'm going to put my x first. So -5x and then -4. And the y has a negative in front of it, which is kind of like a -1. So I'm going to go ahead and divide by -1, divide by -1, divide by -1. So now the y is all alone. -5 divided by -1 is +5. X. -4 divided by -1 is +4. So that means that my y-intercept is +4. And if I want to write this number like a fraction so I can do my rise over run, I'll put it over 1. So that means I'm going to go up 5 and to the right 1. So 1, 2, 3, 4, 5 over 1. And then I'll do the opposite. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. And there is my equation. Okay, I know this is getting long, but I want to do one more problem over here on the back because I do think the cover-up method is pretty cool. So we're going to do this example, we're going to use the cover-up method. So for the x-intercept, I'm going to cover up the y. And that gives me 2x equals -24. 2x equals -24. I'm going to divide by 2, divide by 2, And so x equals negative 12. And that means that our x-intercept is negative 12, 0. And this only goes to 10, but it's not a big deal. See? Add 2 more boxes. There's negative 12. No big deal. All right, and then for the y-intercept, I'm going to cover up my x's. And I have negative 6y equals negative 24. And I'll go ahead and I'll divide by negative 6. And I get y equals 4. And so the y-intercept is 0, 4. And now I've got 2 points, and I can go ahead and connect them. And there's my line. Okay, so those are the notes that you should have in their completion. All of this page front and back, and then just 3 of the examples on this one. What you're going to be doing next is you're going to be graphing these equations. So this is one PDF right here. It looks like this. And then there's a PDF that says equations on it, and this is that PDF. It looks like this. So it's important to open this one up. You don't have to print it or anything. And so what you're going to do is you're going to graph each of these equations. And when you graph them, they're going to go through one of the zombies, only one. They're going to go through one of the zombies. And then when you figure out which one they go through, you can write the letter of the equation down here, wherever they match up.